So you will come to a consensus on each of these 9 statements, whether you think it's true or false, and be able to justify it if possible. So like if you add 2 even numbers, you'll always get an even number. Decide in your groups if that's true or false. If you subtract an even number from another even number, you'll always get an even number. And then go down the list and have some justification for when it is or false. But these will be your groups probably until the next unit test, or if I think that there's some bad combinations, then I'll change them slightly. But for the most part, these are your new groups. So you tried it out a bunch of times and you never came across a situation where it was false. Yeah. Okay. Table 7, Anthony, number 2. If you subtract an even number from another even number, you'll always get an even number. True or false?
Yes.
Okay, justification.
It's like 8 minus 2 minus 4. It's always.
Okay, so always even. And the first one is 2 plus 2 is 4. Okay. Table 1. If you add 2 odd numbers, you'll always get an odd number. True or false? And why? Sorry, what did you say? 3 plus 3, which are both odd, equals 6, which is even. So for the false one, you just have to find one time where it's false, and then that's justification enough. The other one, you probably have to do more than one try to see, but it's possible to do all the possible combinations of even numbers, right? But find enough that are correct, and you could justify it that way. But for the false ones, you really just need one time for it to not be true, for it to be correct. Table 2, what about number 4? If you subtract an odd number from another odd number, you'll always get an odd number. And what's your justification? 17 minus 7, both are odd numbers, but you get 10, which is even. So that's justification enough. Table 3. If you multiply 2 even numbers, you'll always get an even number. True or false? Okay. So all the combinations that you tried, you always get an even number. Okay. Can anyone think of one where it's 2 even numbers multiplied together and you get not an even number? All right. So then table 4, if you multiply 2 odd numbers, you'll always get an odd number. True or false? That's right here in the middle. Okay, false. What is your justification? Well, 2 would be even. So we need 2 odd numbers. Can you think of any 2 odd numbers that we don't get an odd number? Ten is also 5 times 3, we get 15, which is also odd, so that justifies this. Does anyone have one where we get an even number as an answer? So then do we want to change this to true? Okay, so no one can think of one where it says otherwise. So if you multiply 2 odd numbers, we'll always get an odd number according to us trying and not being able to find. Table 6. If you multiply 2 integers, you'll always get an integer. True or false? Okay, why do you say true? Do you know what an integer is? Could you describe it? Anyone in that group? What's an example of an integer, guys? Well, it's a number, it's a type of number. It can be negative numbers, so integers can be negative. Can they also be positive? Are they ever fractions at all? So can integers also be like fractions or decimals of some sort? They cannot be. All right, so integers are like positive or negative whole numbers, except for that whole numbers are only positive. So it's non-decimal, non-fractional numbers. Okay, just so you know, that's what an integer is. So like -1 times 1, we still get an integer. -5 times -5, we get 25. That's still an integer. It just can't be like a decimal of some sort. So we can't multiply two non-decimal numbers and get a decimal, right? You agree with me? Okay. So then back to the top, table 1, if you add two integers, you'll always get an integer, true or false? Okay, what's your justification? Okay, so integer plus integer, we still get an integer. Can anyone think of where we can add some integers and not get an integer? Okay. Table 2, number 9. If you subtract one integer from another, you'll always get an integer, true or false? Any justification at all, or? Okay, we get 1. And can anyone think of a reason that we would get a non-integer? All right, so let's see if we were 100% right. I have it copy and pasted the key down here, as well as their reasoning. So like, there's probably a ton of examples you could have for why something is true or false. These are theirs if you want to read, because you could be wrong in your reasoning. You could say stuff that is not actually accurate, but for the most part, you guys said stuff that is accurate. So 1 and 2, we both said true, so good job. 3 and 4, we both said false, which they are false. And here's other examples that they have that disprove what that statement said. And then for the rest of them, we said true, which is what this says. Okay, and this will be in the notes in Schoology, just so you know if you want to check out their reasoning. But so far, like, no one said anything that was outlandish other than like forgetting some of our like evens and odds, but you guys know them. You guys just forgot for a second. Okay, so questions on that? All right, so then now we're going to talk about something called a polynomial, which you need to know for this upcoming unit. So we're in unit 6 now, and it's called Introduction to Quadratic Functions. So we've done linear functions, we've done exponential functions. Now we're doing quadratic functions. We'll talk more about those another day. Before that, you need to know what a polynomial is. Does anyone by chance already know what it is? Okay, so they're basically like, it has a bunch of words here, but honestly, these words even kind of confuse me. So in layman's terms, it's a multi-term expression. So do you guys know what terms are? All right, if not, then look down at this picture that is also printed on your paper if you have that side. But here it breaks down the difference between terms, coefficients, constants, variables. Hopefully you know what those are. If not, look at this and now you know. So coefficients, are the numbers in front of a variable, like 8 and 5 in this example. So I would probably add more words if you don't know these by heart. Coefficients are the number in front of a variable. So like in this example, would 6 be a coefficient? And why not?
Morning, Shadow.
All right, so the question was, is 6 a coefficient? And why is 6 not a coefficient? It's not in front of a variable. Good. So coefficients are the numbers in front of a variable. If there's no variable, then it's what we call a constant, or in like layman's terms, single number. Okay, so 6 is a single number. And if you think back to when we had to make the equations for like a word problem and stuff, it was what wasn't changing in that word problem. So like, say this represents how you get paid. Well, then the 6 would be like your starting amount, like just for showing that. You always get $6 out of it. Or it could be a bunch of different things. The constant is what never changes, like in a word problem. That's why it's not multiplied by anything. Okay? Terms. What are terms separated by? Like, how do I know that this is term 1, this is term 2, and this is term 3? What's a good, like, way to separate that? By the what? The word?
The minus and plus.
So, yes, I like that better. The plus and minus signs are like other operation symbols are what separate your term. So that's why I have 3 here. And for each term, keep the sign that's in front of each term. This one, we usually don't write if it's positive, like we don't put plus 8x squared. But if there's no negative, we know it's positive. This one is negative because you keep the sign that's in front of each term. And this one is positive. So if for some reason I wanted to reorder this, just make sure that you keep the sign in front of each term. Like if I wanted to write this first, just make sure you still keep it negative. Make sure you still keep this positive. And then the 8x squared was positive. All right, just FYI. Keep the sign that's in front of each term. Variables, I hope you know what those are already. Those are the legs. Question? So that's like parts of a polynomial 101, right? I'm going to go back to our definition of what are polynomials. So polynomials can be used as like a general way to describe multi-term expressions. So they might say classify this polynomial. And if they say that, they're asking you to classify it by the number of terms. So there's 3 different types. There's monomial, which what does mono mean? One. You probably heard that in science. Mono means 1. Binomial, which what does bi mean? 2. Trinomial, let me highlight tri. What does tri mean? 3. And then I have polynomial, which what does poly mean, if anyone knows? No one? Based on like the trend, so monomial is 1 term, binomial is 2 terms, tri is 3. Actually, it's many. Okay, so 4 terms and up. So a polynomial could have like 5 terms and it's still a polynomial. 8 terms, it's still a polynomial. So poly means many. Okay. But again, they might say classify this polynomial and really it's a monomial. So just understand that. And here's the examples, right? 1 term, 2 terms, 3 terms, and then 4 and up. So if they ask you to classify a polynomial, it's by the number of terms. if they ask you to classify by degree, that has to do with exponent. And I'll show you a few examples of that. And the way that I've always learned it and taught it, for some reason it varies slightly, is that if you have like a term with multiple variables, you add all those exponents. So like, what is the exponent on this e right here? What's the exponent if it's not written? What was that? It is 1. So it's e to the first. And what's the exponent on the cube? Also 1. So the degree of this first term is going to be 2, because 1 plus 1. What's the degree on this middle term? Does it have multiple variables? Right, it doesn't, it just has the 1x, and it's to the second power. So you add up all the exponents, that degree right there is 2. The 10 doesn't have a variable, does it? So guess what that degree is going to be? 0, because it doesn't have a variable at all. The overall degree is going to be whatever the highest is. So like for this trinomial, this is going to be known as a second degree trinomial, because it has 2 as the highest degree overall. So that is the overall polynomial. All right, does that make sense? So down here, write that overall degree is the highest degree on any single term. Doesn't necessarily have to be on the first term, just whatever is the highest degree overall. So you have a degree of a term and a degree of the whole polynomial. All right, so what's the degree on this x, on this 4x? When Aubrey comes back. Table 1, everyone sit up. So, Brianna, what's the degree on this x right here? I'm not sure that's thinking. Aubrey, what's the degree on this x right here? Or, sorry, not Aubrey, Jordan. Jalen. Okay, so again, let me repeat it because we have some people not paying attention. So degrees have to do with the sum of the exponents on a single term. So what's the exponent on this term? 1. Are there any other variables on this term? So then class, what's the overall degree on this? 1. So guess what? This is a first degree. And what type of polynomial is it? A monomial. There's only 1 term. So you can classify it by degree and by term. They're both different. So you can have like a 5th degree monomial if you want, but that's how you classify it. Briefly, like in your head with your groups, classify this one based on degree and number of terms. Give you like 10 seconds. All right, table 7, what's the overall degree on this? No. Table 2, what's the overall degree on this? Degrees have nothing to do with the coefficients, guys. Just the estimate. So table 3, do we know the overall degree? So this one's a second degree, sorry, I switched tables. This one's a second degree, and then what type of polynomial is it? A binomial. Okay, so if you got that right on your first try, good job. If not, degree has to do with the exponent. So like, this first term has a degree of 1. The second one has a degree of 2. Whichever is higher is the degree for the whole thing. Okay? That's why it's a second degree binomial. Question? All right, you'll have more practice with that tomorrow, just so you know. I'll leave a video for you to watch and notes for you to take, and then we'll do more practice with this. Just so you know. And it'll be due during the class. All right, so scrolling down. Now here's some more kind of like what we did in the warm-up. If you add or subtract 2 polynomials, will you always get a polynomial? So talk about that in your groups. And then also talk about if you multiply 2 polynomials, will you always get a polynomial? Kind of like how we did before, decide if it's true or false, and if you think it's false, provide a justification. So let's put it to a vote. So for the first one, if you think that it is true that if you add or subtract 2 polynomials, you'll always get a polynomial. So if you think that that is true, raise your hand. Okay. If you think that that is false, raise your hand. Okay. So there was an overwhelming amount that said false. Any reason for that? Like, can anyone provide any reason? Yes? Okay, so those would be all constants. Let me see if it matters if it needs to have an X. Okay, so according to the definition of polynomial, which again, I think this definition is kind of funky, it says you need to have like letters in there, essentially. So what we're really asking is if I add or subtract 2 polynomials, say it's like 2x plus 3y minus 4, you can have some constants in there. And then we add or subtract another polynomial, 3x squared plus 4x plus 10. Okay, so these are both trinomials, but they fall under the category of polynomials. Would I still get a polynomial? Does anyone think otherwise now? That you want to change your vote? All right. So normally when you add 2 polynomials together, so like if this was being added to this, normally you have to have it in parentheses because you're adding like one set to another set, right? What is outside of parentheses always, even if it's not written? A 1 being multiplied by it. Now, does multiplying by 1 really change anything? No, so that's why a lot of people get like this false impression that they can just like drop the parentheses. Like sometimes that works if it's a positive 1 on the outside, you can just drop the parentheses and then add all the like terms, right? But then if this was actually where we were subtracting instead, if we were subtracting this polynomial by this polynomial, what's outside this parenthesis? A positive 1, what's outside this parenthesis? And doesn't multiplying by -1 like change stuff? So it actually changes all the signs that are in there. So that's why what I tell my students is don't forget to distribute the 1. Yeah, sometimes it does not make a difference at all, like in this first situation. But in the second, it does, it changes all of the signs. It becomes minus 3x squared, minus 4x, minus 10. All right, and you'll do more practice with that tomorrow. But then from there, how do you know what to add together and what to leave? We can only combine terms that are alike, so I can only combine like terms. Can this 2x be combined with anything? What can it combine with? Actually, the negative 4x, because these have this x to the first power. Those would be like terms. What's 2x minus 4x? Negative 2x. And then see, like, if there's other like terms. So, like, does this 3y have a like term? No, but it doesn't go away, so you still write it in your answer. Does this negative 4 have a like term? What's its like term? Yeah, constant can always be combined. What's negative 4 minus 10? Negative 14 for time's sake, but yes, you could use a calculator. And then does this negative 3x squared have a like term? No, but it doesn't just go away. So I added or subtracted 2 polynomials. Is my answer still a polynomial? Yes. So in the book, it said answers vary, so I'm not sure what that means. I guess it could depend on like if you're using like the formal definition of poly, which is 4 or more, or if you're generalizing it. But I would actually say that is true. Even if you get just one term remaining with an x. I don't know. But you guys will have a better practice, a better video to follow. So like